All right, these are the notes that we did today in class. Is Monday, October 15th, and we took these notes over ions and isotopes on page 48 and 49. We did guided practice on one side and these notes on the other. So we really talked about ions and isotopes, and we said the first thing is that all atoms have two forms. You have ion form and you have an isotope form. So we remembered that ions always means charged. Definitely, anytime you hear the word ion, always remember charge. And what happens here is that an ion is made by when there's changes to the electrons, only changes to the electrons there. And that's what gives the atom to have an overall charge. So there's two ways that you can change the electrons. The atom, if itself, can give away or lose electrons. And if it does that, it becomes positive, and we call that a cation. So again, if it gives away or loses electrons, it becomes overall positive because, remember, electrons have a negative charge. So if I'm losing negative charges, overall, you're not losing any positive charges from the center, so overall your atom is going to have more protons than it is electrons, so it's going to become positive. If I gain electrons and I'm an atom, I'm going to become negative overall, and I'm called an anion. And here's some examples here of ionic notation. So this is Mg with a 2+ charge or +2 charge, either way. You can put the positive in the front or behind. This means that it has an oxidation number or an ionization number of +2. So magnesium means that it has lost 2 electrons. It's got an overall 2 charge. Sodium has a +1 charge. So sodium has lost 1 electron or given away 1 electron. Oxygen has a -2 charge. So that means that oxygen has gained 2 electrons. So from this ionic notation, you can tell the element, you can tell if it's lost or gained, or if it's a cation or an anion, and you can tell how many electrons that it has lost or gained. So again, this is always changes to electrons. There are no changes in mass because electrons are so very tiny. It takes 2,000 electrons to equal the mass of 1 proton or 1 neutron. So electrons do not change the mass at all. Now, on the other hand, isotopes, they are dealing with changes in neutrons. So changes in neutrons are isotopes, and it will change the mass. So isotopes have different masses from each other. However, they do not have different charges because neutrons are neutral. So we looked at this example here. We compared iron 50 to iron 56. This is a dash. It's not a negative sign. So iron dash 50 and iron dash 56. Those are two isotopes of iron. And we compared their protons, neutrons, and electrons. Well, you can see here that iron, if I look at the periodic table, iron is Fe. And I'll get my periodic table out. Iron's right here. So Fe is iron, and it is 26. So I have 26 protons in both of those forms. Now, how many neutrons do I have? I have to subtract my mass, which this is my mass. Iron dash 50 has a mass of 50. So 50 minus my protons, which is minus 26, is going to give me 24. Iron dash 56 has a mass of 56. So 56 minus 26 is going to give me 30. Now my electrons, remember I said that isotopes don't have a charge. So if protons are positive and electrons are negative and I have no charge, those two numbers have to equal each other because a positive 26 and a negative 26 equals 0. A positive 26 and negative 26 equals 0. Now, what I'm going to do is I'm going to put up the answers to the first 10 on your guided practice, so you can pause those. These are the ones I went over in class. Most classes got to look at all of those answers, so there's that. And I'm going to finish up 11 through 20 with you. So you can pause the video and get those answers and then start it back, and we'll work through these. You notice I went ahead and I went through the periodic table and got the atomic number and the average atomic mass for each one of these before I started to kind of save time. And then I'm going to look at...
Anna Fletcher, if you are in the school, please come to your mama's office. Anna Fletcher, if you're in the school, come to your mama's office.
All right, so we're going to look at ionization charge. So the charge is given to me over here in the name. So this aluminum has a -3. Phosphorus has a -3. Sulfur has a -2. Chlorine a -1. Potassium a +1. Arsenic a -3. Selenium a -2. Bromine a -1. Rubidium a +1. And polonium a -2. So that's how I do the charges. It's given to me in the name. Now my protons are going to be the same as my atomic number. So 13, 15, 16, 17, 19, 33, 34, 35, 37, 84. There's my protons. Then my next thing is my neutrons. I'm going to have to subtract that. So I do 27 minus 13. It'll take me just a minute. I should be able to do these in my head, but I'm not. 31 minus 15 is 16, and this one's 16. That's 18, and this is 20. And 75 minus 33 is 42, and 79 minus 34 is 45, and 80 minus 35 is 45, and 85 minus 37, I had to think about that for a second, 48, and then 209 minus 84 is 125. So that's how I found my neutrons. You take the mass and you subtract the number of protons every time, just a little subtraction problem. So over here I have to figure out my number of electrons. When I look here at this one has a -3 charge. That means I have 3 more electrons than I have protons, so I would have 16. This one has a -3 charge. I have 3 more electrons than I have protons, so that's 18. For this one, I have 2 more electrons than I have protons, so if I have 16 protons, I have 18. In this one, a -1, that means I have 1 more electron than I do a proton, so that's 18. In this one, I have 1 less electron than I have a proton because I have a +1 charge, so that's 18. If I do a -3 here, that means I have 3 more electrons than I do protons, which is going to give me a 36. I have 2 more electrons, than I do protons. 2 more, -2 charge. -1 charge means I have 1 more electron than I do a proton. +1 means I have 1 less electron than I do a proton. And -2 charge means I have 2 more electrons than I do a proton. So there's the answers for the ions. Now let's look over here to isotopes. These are the answers for the ones we did in class, and I'm going to finish up this page with you. I went ahead and got their atomic numbers, so I didn't have to sit here and search for them, but those come straight from the periodic table. Their atomic masses are given to me. So iron 54 has a mass of 54. You're not going to use the masses that are on the periodic table. You're using the mass that's given to you. So that's 60, that's 65, 60, 200, 225, 50, 40, 230, 240. The ionization charge for any isotope is 0 because their protons are coming from here, and so are their electrons. So their electrons and their protons are the same as their atomic number because they have no charge. So I'm just filling those in, and I'm leaving those other ones till the end. And that's coming directly from that atomic number. Now, I do have to do my subtraction to get my neutrons, and then I'm good to go. So 54 minus 26 is 28. And then 60 minus 28 is 32. And then 65 minus 29 is 36. And 60 minus 29 is 31. And 200 minus 86 is 114. 225 minus 86 is 139. 50 minus 21 is 29. 40 minus 21 is 19. 230 minus 92 is 138. And 240 minus 92 is 148. All right, if you caught an error on that, just let me know. Check my math because I was doing that really quickly. So there's your answers to the other 10. Now, I'm going to flip onto the back, and I already have these done. And I'm just going to post the answers. But I'm going to, before I post the answers, I'm going to do the first 3 with everybody on each side. So if we look at the ion side here, this is all about ions, and it gives you the charge. So like this is magnesium with a +2 charge. Magnesium is number 12. The average atomic mass is 24. That comes from the periodic table. And then my number of protons is 12. My neutrons is 12 because 24 minus 12 is 12. And then if I have 2 more protons than I have electrons, I would have 10 electrons. For this one here, I don't know what it is, so it gives me the number of protons. Well, I know that is also the atomic number, so I have to kind of work backwards. So I have to look here at 51, and I find, oh, that's antimony. That's 51 Sb, and I do find that it has a mass, average atomic mass, on the chart of 122. Is what it would round to. And then I have to look for the charge. So the charge is going to be the difference in my protons and electrons. So there's a difference of 3. Now I have to decide, is that going to be positive or is it going to be negative? Well, I have more electrons than I do protons, so you're going to take the charge of the electrons there. So that's a -3 because more electrons. Neutrons, I have to do it just like I've always done it, 122 minus 51, and I get 71. So for this one, it gives me the atomic number of 35, so I go to the periodic table and I find out that 35 is bromine, and bromine does have an atomic mass of 80, or 79.9, and we round it. So the protons are 35 because the atomic number is 35. Electrons, it has a -1 charge, so it's going to have to be 36, and then 80 minus 35 is going to give me 45 for my neutrons. So there's that. I'm going to put this one up here, and you can pause the video there and then pick up in a second after you check your answers. All right, let's look at the other side on the isotopes. So my protons, I have to go for this, in this case, I have to look at the periodic table to find chromium and to find its atomic number, because that's going to tell me protons, and chromium is number 24. My electrons are going to be the same as my protons because, remember, isotopes are neutral. So these two numbers are going to always be the same. So if you're given them, you can go ahead and fill those in like that, and so on and so forth. And I'll put all the answers up in a minute. So my neutrons here is I got to take the mass, which, remember, this is my mass, minus my protons. So 54 minus 24 is 30. And the mass, remember, is 54 because it's given to me in the name. So zinc 67, if I look over at my periodic table, I find out that zinc's number 30. It's neutrally charged, so they're going to be equal, protons and neutrons. So 67 minus 30 is 37, and the mass is 67 because it's given to me. Well, this one I have to look at, well, what is number 40? And number 40 is zirconium. So I have to write out zirconium dash the mass. The mass is 90. So this is actually zirconium 90, and then I'm left to figure out neutrons. So 90 minus 40 is 50. So I'm going to post the answers for this side, and you can pause the video and get the answers for that. Now, when you're done, I'm going to post another tutorial video, not me teaching, but somebody else, to how to do stuff like this if you would like to watch that. And then also, when you're done, you need to be doing, do this sheet like this for a grade, work on your vocabulary task for Unit 4, and or your Ed puzzle for Unit 4. Those things, those 3 things, need to be due by Wednesday. All right? And I will see you Wednesday.